various stages of formation of a temperate cyclone. So the formation of a temperate cyclone, as you can see on your screen, is accompanied by various different stages. It is not as if suddenly there will be a temperate cyclone and suddenly that cyclone will end up disappearing. No, there are various processes which have to happen in order for that cyclone to develop. It starts with the first stage, that is cyclogenesis or the stationary stage. Now, cyclogenesis is a term that you will come across multiple times both in the case of temperate and tropical cyclones. What do we mean by the term cyclogenesis? So, this cyclogenesis is formed by combination of two different words, cyclones and genesis. Genesis means to be born. So, first stage can always be regarded as the birth of the cyclone. Then after that, you have the beginning of a young adult. Then after that, we have the mature phase or the phase in which the cyclone is at its intensified best, or the stage where the wind velocity is at its maximum. After the mature phase, slowly and steadily the cyclone starts dying. And we have seen about the formation of an occluded front earlier. So that is why the next stage is referred to as the beginning of occlusion. Occlusion means what? To close down. So the fourth and the fifth stages are when the cyclone eventually dies. When the cyclone dies, that is also accompanied by the refurbishment of the fronts in its initial position and also what is referred to as cyclolysis or the death of a cyclone. Now, let us look at each one of these stages in detail and let us understand the formation of these different stages and overall the formation of the temperate cyclone. So to begin with, the first stage, which is the cyclogenesis, is also referred to as the stationary phase or the beginning stage. Why is it that it is referred to as the stationary phase? That is because if you look at the figure here, this figure typically ends up depicting the stationary front. And here, as you can see, you have different air masses. You have warm air mass on one end and you have a cold air mass on the other end. So, it is the very beginning of the interaction of these different air masses. That is why referred to as the beginning stage or the stationary stage. Now, in this particular stage, even though the different air masses are quite stationary, there does exist a temperature difference as well as pressure difference between these two regions. And slowly and steadily, you will find that there are differences in pressure gradients which leads to movement of warm air mass into the colder region and cold air mass into the warmer region, which is followed by the next stage. But the typical characteristics that you can associate with this particular stage of temperate cyclone is that there is a sense of stability. Even though there is a temperature and pressure difference, but that ends up appearing slowly and steadily as these air masses end up interacting more. But in the first stage, they just appear in front of each other and the instability is not very, very high. So with the passage of time, gradually, you will see that there is an interaction between these different air masses along the contact zone. That is, along this region, there is generally an interaction. The warm air mass will try to intrude into the cold air mass along this region, and the cold air mass will try to intrude into the warm air mass into the other region. So that is what leads to the second stage of the cyclone formation, which is also referred to as the beginning of a young adult. Here, young adult is referred to in terms of the life cycle of the cyclone. That is, at this stage, the cyclone is not very developed, but it has moved on or it has transited into a greater phase when compared to the cyclogenesis or the birth of the cyclone. So in this stage, you will see that there is an interaction which has developed and there is formation of a typical front which starts moving, and the warm air mass ends up intruding into the colder region, and the colder air mass, being heavier and denser, starts moving rapidly into the warmer region. So, in this particular stage, what we end up experiencing is that the frontiers of two air masses, they end up being very, very different, and the transition is very apparent when it comes to these two air masses. Also, because the warm air mass is significantly lighter in density as compared to the colder air mass, this warm air mass is pushed up the cold air mass. What do we mean by that? So, here you can see that cold air mass lies on one end and the warm air mass lies at the other end. We know that cold air mass is typically very condensed in volume. So, when the warm air mass comes, this warm air mass ends up rising over this colder air mass. So, you will see the warmer air mass, it ends up rising over the colder air mass. Now, what happens when this warm air mass rises over the colder air mass? That leads to formation of clouds. That is because there is condensation which is observed as and when the warm air mass interacts with the cold air mass. So, at the boundary region, upon reaching a particular height, the temperature drops quite significantly, and due to this particular condensation, what is released is latent heat of condensation. So, as and when this warm air mass climbs up, as and when there is formation of a cloud, that is what is formed due to condensation. And this condensation ends up releasing heat in the form of latent heat of condensation. So, at the junction of these two different air masses, due to the formation of these clouds, you will have or you will end up experiencing rainfall. But this latent heat of condensation that is released, what does it do? It will further heat up that particular region. And due to that particular factor, the low pressure which was formed, that low pressure intensifies even more. So in this particular stage, you experience intensification of low pressure. And this intensification of low pressure further attracts winds and is a precursor to the fully developed cyclonic stage, which we refer to as the stage 3 or the mature stage of the temperate cyclone. So in the mature stage, as you can see on your screen, the air masses have gained a significant amount of direction in them. You will see that how warmer air mass end up rising through the incline, and conversely, you will find that how the colder air mass ends up intruding into the region of the warmer air mass. So you will have formation of a cold front as well as the formation of a warmer front. So due to this particular factor, you will find more amount of clouds being formed and more amount of rainfall occurring in that particular area. Every time there's a formation of a cloud in that region, that will always end up releasing latent heat of condensation, right? Now, here you have to understand that typically, as you can see, the cold air is closing in and intruding in the region of warmer air. So, cold air continues its movement and continues to intrude in the area of warmer air. So, that is why you will see that by the end of second stage, the low pressure which was formed, it starts intensifying, and this attracts air from the surrounding region. It is this air which comes from the surrounding region which is experienced as winds that we talked about, having a velocity of around 30 to 40 km per hour. And because there is intensification which is happening, the isobars which are formed around this low pressure, they start coming closer to each other. Due to that, the winds, while approaching this whole area, they are moderately speeded. As and when they come very close to this area, their velocity ends up increasing quite significantly. Also, the pressure gradient is very sharp and the invasion of cold air mass is now very, very apparent, while the warmer air mass, which you would have earlier seen occupying half this space, is basically now restricted to the smaller region. So here, more and more sharp turns of the two different fronts of these air masses are experienced, and that is why you end up observing a mature phase of these cyclones. But as I said, after the mature phase, the cyclone comes into the later stage of its life. That is, after that, the dissipation process starts slowly, or the occlusion process starts beginning. So, the fourth stage is referred to as the beginning of occlusion. So, in this stage, you will observe that whatever you had seen under the mature phase, that is much more intensified now. So, the colder air mass shall be enveloping the warm region from all different sides, whereas the warm air which is now restricted to the smaller area, that warm air starts rising up quite vigorously. And on the ground, this warm region is being encapsulated and is being enveloped on all different sides by this colder air body or the colder air mass. So, when you talk about occlusion, occlusion refers to the act of closing, blocking, or shutting something, or being in the state of being closed or beginning of closure. So, always, if you have to understand what do we mean by being closed, being open, and so on, compare this figure to the figure that we saw in the first stage during cyclogenesis or the beginning stage. You would have observed that in that particular stage, there was a very distinctly divided cold air mass section and the warm air mass section. But now, if you look at this particular figure, you would observe that how the region of colder air is slowly increasing and slowly expanding. That is because the colder air which hugs the ground is easily able to uplift the warmer air which is having a lower density. And also, warmer air being lighter can easily be uplifted by this wedge of cold air which is following the ground. So, in this stage, the cyclone starts declining as the low pressure eventually gets weakened. And in this stage, the wind velocity also starts reducing. So, the low pressure that is formed, that low pressure and the strength of that low pressure weakens quite considerably, leading to the last stage in the formation of the temperate cyclone, and that is the late occlusion, or what is also referred to as the dissipation phase, or the phase in which the cyclone ends up disappearing after all. So in this stage, you will observe that the cold air mass has encapsulated the whole region, and what was earlier a significantly different front which was depicted, that front is now completely closed. This is the region where we ended up experiencing the formation of cyclone in various stages, be it in the phase of a young adult or be it in the phase of a mature cyclone. So this particular region, as you can see, has virtually been closed now, and for all matters and purposes, this whole area is covered by colder air mass. So that is the last stage in the whole process of formation of temperate cyclones. So in this stage, if you will observe, then more and more areas are occupied by the colder air mass, and even those regions which had warmer air, that warmer air is pushed upwards. And as warmer air is pushed upwards, we have seen earlier that this warm air ends up expanding and there is an adiabatic cooling which is observed, and the temperature of the warm air also ends up dropping. So if you will revise the basic concept of the formation of cyclones in the case of temperate regions, it all started with different air mass having a variability of temperature and pressure conditions. But then, if you look at it, then in this particular stage, warmer air mass also ends up cooling down. So due to this particular reason, the temperature difference between the warmer air and the colder air ends up disappearing completely. So that is why the cyclone also ends up dissipating. So that is the end of the cyclone, after which the fronts re-establish their region as was the case before the beginning of the cyclone. So overall, if you will look at it, then this cyclone can be referred to as the formation of a disturbance at the point of transition of different air masses and the development of these air masses into an atmospheric phenomena or disturbance which leads to significant amount of rainfall over a larger area, but then eventually ends up regaining its original position where these air masses again have a clearly demarcated region of their own. So that is all that you need to know in the case of temperate cyclones.